Okay, let's get started. Welcome to another Common Lisp study group. I'm your host, Ron Batum with Atlanta Functional Programming. Today we're going to be continuing our application development exercise that we've been doing last week with building a demo for reading in FLAC metadata from a FLAC file. I went ahead and posted the GitHub repo with all this information. It's actually located in the YouTube description. Folks who are on the Hangout, it's in the chat window. Let me know if you guys have access to it. It should be there. It should be a public repository. I went ahead and did some cleanup, primarily things like being able to, I moved stuff around. Actually, it looks like I forgot to take out this comment here. I moved stuff around, created a couple of packages, exposed the internal functions that we wrote in those packages for like primitives and stuff. And if you actually go and look in that directory, there's read primitives, which will give us, if you recall last episode, we went ahead and wrote a bunch of nice convenience functions to read bits and bytes, and the reading unsigned integers from bits and bytes using the bit.io library and so forth. As well as reading strings for getting some of the metadata out using Babel. In addition to that, I also created, we had, if you recall last week, a class that we created called Buffer that held all the information for our FLAC file with some convenience things for reading it in the different forms as to reading either a bit or a byte or a stream or a sequence. And some accessors associated with them.
Can you make your windows horizontal? It would help a little bit with
horizontal or vertical? Yeah, sure.
Yeah. With that font size, it's just like hard to read only a couple lines at a time. Oh, much better.
Okay. Let me just go ahead. Adjust this. I can. The reason is with the word wrapping, it looks kind of weird. But if this is what other folks are cool with, we can go ahead and do that. So
you can make your REPL smaller. I mean, that doesn't need to be a whole half of your screen. If you want to make the main window bigger, I mean.
Yeah, sure. I could do that. That's probably a better idea. I'll do that. This guy here. No, not there. There we go. And let's go ahead and shrink this guy down. All right.
Or that, yeah, okay.
This I actually tend to code like this with a small REPL screen at the bottom, but
yeah, most do.
All right. So let's go ahead
and we should probably like review the thing we blazed through last week because that made probably no sense to most viewers.
The read string, yeah.
Like the buffer thing and yeah, everything like that.
Yeah, absolutely. Let's go back to buffer. In addition to our class of buffer in our convenience methods, we also wrote last week a macro called with buffer that takes in the buffer, attaches it to a stream, so that we can actually, make it easier for ourselves to actually go through and access the
Well,
internals of the
this
buffer.
is actually in my opinion, a very good use of a special variable. And the reason why is, well, if you, I don't know if it would be readable, but can you open up your the main FLAC parser file
Yeah, sure.
in a side buffer?
Let's do this. I'll do this. Lisp.
Okay, so right where that comment is there that says parse stream into FLAC metadata. Oh, we already have. Okay, so with buffer, and then we're passing in the keyword stream with our with open file stream. That sets the initial binding of our special variable buffer, and our whole parsing is going to be within that let FLAC metadata and then parse whatever here. All of our function calls are going to be within the scope of that root binding for buffer, and that's a stream. However, anywhere inside of any of those function calls, we can call with buffer again to shadow the original buffer binding, and that time we could pass in like a vector, and we could keep nesting those, and this gives us a really nice ability to be able to basically rewind the stream for free, because when one of those scopes ends, then the binding is popped off the stack, and we're back to the previous binding.
Right.
So it's a really nice way to manage streams and reading bytes from the stream really nicely without doing any rewinding math or anything like that.
So the shadowing gives us the ability to, in some cases, be able to like point out to various parts of the streams without having to worry about clobbering the previous scope's pointer, right?
Right. Yep.
Okay.
But yeah, that with buffer, so what it does is it basically, when we like the FLAC format, it's separated into blocks. And so what we would probably do is we would say, okay, the first block, it's called stream in the specification, and it's a certain amount of bytes. So we would call with buffer with that many bytes to put that whole buffer into memory, and then we could read individual things out of that buffer, and when we're done, we read another. It's pretty simple. So that whole with buffer thing, it's just managing the state of all the bytes that need to be read, as well as all the bits. Because like if we were to read, a byte from a stream, but we only needed like 2 bits out of that one byte, we would have to do something with those remainder bits. We would have to cache them somewhere to be able to, use them next time we read a byte or a few bits or whatever, and that's just a big mess waiting to happen. So this bit.io library handles all that, and fast.io is another library that just manages reading bytes from a stream or a vector, and those two actually play well together. So this is just a nice abstraction over that to be able to not have to worry about any of that.
Yeah, but that's actually one question I had. When you're reading bits out of the byte stream, how does are we still technically only reading bytes? And the bit since we're caching the bits here,
Yeah,
once
well,
we read
bit.io
it.
does that automatically.
Oh,
It knows how to work with a function that looks like Common Lisp read byte or read sequence. And fast.io is one of those libraries that has the same syntax and API as the Common Lisp functions for reading sequences and bytes and everything. So whenever you request X bits with bit.io, it goes ahead like say it was 5 bits, it goes ahead and reads a whole byte, and it keeps that remainder around for the next time you call, like read bits or read bytes or whatever.
Okay.
It knows what to do. That's all behind the scenes by bit.io.
Okay. Because we're using fast I/O for reading bytes. If I did not,
we're actually using bit.io, but it knows how to use fast I/O because we told it to with that
this fast read byte here. Right here.
There was read bit sequence.
Oh, read bit sequence.
Yeah. Okay. Our function that we wrote somewhere, I think a little bit higher in that file.
Yeah. Okay. Yeah, read bit sequence. Got it. Okay. Okay, that makes more sense. All right.
Yeah. So it knows how to call into that to do its magic.
Right. Okay. So before we actually get started on actually reading the FLAC file itself, there's one more thing we did not do last week that we postponed to this week, and that is the creation of this FLAC metadata class. This does not exist right now.
FLAC metadata.
This is actually getting started with the actual file format, if I'm not mistaken. Right. So we have to actually document that. So let's go ahead and do that. Let me create a new file. Let me just go ahead. Actually, I'll just do it in here, and then I'll move it around if I need to.
Yeah, right there is fine.
Yeah. I'm going to close this one so we have some room. Okay. Def class FLAC metadata, assuming we're not inheriting from anything. Okay, so if I'm not mistaken, the first thing is there is a.
Well, that's your root object. You're not gonna be putting any parsing stuff into there. Really, right. All you need in that root object is probably the file path, so we can, return that later. Because we're getting that in the read FLAC stream function, so we can just pass that as an argument. And we also need like the root container of our concrete syntax tree. I usually call it parse tree, which means the same thing.
Got it.
And we'll have like a function called whatever the first block is, stream, like parse stream, which will start writing into the parse tree, and everything else will too.
Okay, so then this guy will be parse. I don't think this needs an init args, but I'm just gonna go ahead and do it. Actually, you know what? I think we're going to be manipulating this sucker. Okay. Let's go ahead and make that into an accessor. Anything else in here? I think you said no.
Nope, that should be good.
Okay. All right.
So in that comment, all we're going to do is, well, in our make instance, we're going to probably pass in the file path,
right,
as an argument first.
All right.
And and inside that comment, the only thing we're going to really do is setf the parse tree. And we do want to setf it, I think. Wait, let me think. Yeah, I would
setf it just
as an argument. I think you might have to make that an accessor if you have it.
Yeah, I have. Okay. FLAC metadata to be parse stream, I think is what you said.
Yeah, the first block is called stream, not to be confused with the actual stream we're parsing. So yeah, parse stream is good. I would just call it parse dash whatever the block name is.
Got it. So this is, hold on, sorry. This is a function that will take our actual.
I would put that part in another file.
Okay.
Because like each block is probably going to have its own class and a whole bunch of functions to go with it.
All right. So what I'll do is I will go ahead and make a note here. Each part. All right. So let's go ahead and.
Before we actually do that, though, we should test out that our readers actually work.
Got it.
Like you can comment out that set f line for now, just temporarily, and the first 32 bytes of the entire FLAC stream is a string that says FLAC, basically an alternating uppercase and lowercase. So if we read a string and see what value we get, we know that our string is reading the first 4, actually bits, 32 bits. Yeah, 4 bytes, FLAC. So if we read a string of 4 bytes and we get back the string FLAC, we know that our readers work.
Okay. So
you can do that right in there, right after the comment, because it has to be within your with buffer.
Right. So read.
Is that in another package?
Yes, it is.
Did you do one package per file or something? That might get annoying.
I may have done one package. Yeah, I did one package per file just because that's out of habit. I tend to do it to keep everything into a single.
Fair enough.
But that's fine. I thought I actually used everything in here.
Oh, look at that. Jace decided to join this week.
Hey!
Shush. I'm trying to be quiet. Yeah, semester wrapped up, so, you know, cool. I have some time again.
Yay! Welcome back. Yeah, so let me go ahead.
I want to verify all of our stuff we wrote last week actually works before we start writing classes and a whole bunch of functions for working with it.
So it's read bytes is count. So let's see this.
You could do anything. You could do read bytes or read string. It doesn't matter.
You're gonna need to export all those functions.
Oh, thank you.
Yeah, to be honest, I would not use multiple packages per file here because you're going to have a lot of cross-package speak, and you might actually have mutually recursive dependencies among them.
There are ways to solve that.
There are, but I mean, for such a small project, I don't think.
Hey, let's go full force, man. I mean, go.
Well, the trouble is that Michael and I disagree on the proper ways to solve that problem.
No, I agree with your way. It just.
Oh, jeez.
I know what you're saying. I was asking him for assistance with a very large project that was not worth trouble to go and
so my solution to that is that you have separated interface and implementation packages, and what you do is you do one package per file for the implementation packages, but you put all the interface packages in an actual packages.lisp at the start.
Oh, that's the real old way of doing this. I've actually seen, I used to do that, and then I kept seeing a lot of these package generators do one package per file, and I was like, is that kind of...
Well, no, so not, that's the thing, though, is that the interface packages, you don't ever write code in them. Right? You only ever write code in implementation packages, and implementation packages are still one package per file. But the trick is that you only ever do interpackage referencing where the implementation packages reference other interface packages. And then the way that you resolve, the way you actually link everything together is in an implementation package will import the symbols that it's supposed to supply from the interface package that it's supplying them to. And then it'll define something on those symbols. And that sort of ties it all together again, right? And that way, since you've pre-declared your interfaces, and your pre-declaration of the interface includes all the symbols that you're exporting from that interface, you can freely have circular referencing without any trouble, because each of the different implementation packages just references the proper interface package, and then once all the implementation packages are loaded in, everything will be filled in the interfaces. And that solves the cycling. But it also means that you have a lot of extra packages everywhere. And it's a lot of extra typing, and it's, it's questionable whether it's working.
Yeah, and you have a lot of local nicknames probably for each interface package in every implementation package.
Well, that's the thing is you never nickname an implementation package. You only ever nickname.
Yeah, I know. That's what I mean. Inside of an implementation package.
Yes.
Local nickname.
Yeah, you have to local nickname. Yes, but I mean that's going to be true regardless.
Around, but it might be worth it if you have a large enough project.
Okay,
but so I mean that's what it's going to be like regardless. Like,
yeah, yep.
So let's see here. I returned the octet vector, so this guy.
So all you have to, so for this, just call read string.
Okay.
You probably want a string because you want to be able to verify the code chars.
So let's see here. Should I just do it in the LUT then? I guess I can just do it in the LUT.
No, just do it anywhere within that with buffer is perfectly fine because it's going to be the first read thing from that string.
Right.
Just anywhere. Just call it read string. And if you remember, read string, it has 3 ways to be called. We can call it with a set amount of bytes, which is what we want here. We can also call it with the null terminator p argument specified as t, or non-nil, and that'll just read until there's a null terminator in the string. And we can also just say, pass neither, and it will read until the end of the whole stream, basically, in this case.
So here...
So that should work. Well, you don't have to wrap it in a header. Just actually print the value of that, just to see if it, or return it, or whatever. Just to see if it's actually the string we want.
Oh, I see. Got it.
Or just print header at the end. It doesn't matter. We just want to verify that everything works here. You don't have to be code correct, really.
Okay. All right. I've done it.
And now just call that on a file. See what happens.
Okay. Give me just 1 second here. Got to go in and make sure my file exists in my directory. Yes, I do. All right. So let me set package here so I don't have to constantly read flag stream.
No, read flag file.
Oops.
That calls read flag string.
Thank you. It's like, what the heck? Read flag file. And the file path.
Invalid initialization argument. Wait, what? Sequence stream bits and bytes.
That's in the buffer.
Make instance. Okay, so pull up in a little side buffer your buffer file there so we can see what's going on.
Yeah, sure.
I might have made a small typo or something. Can I see your class definition up above?
Yeah, that's what I'm trying to go up there. Bit, bytes.
Arg. Not init args.
Yep.
Dang it! Why do I always do this?
You can have multiple init args, but you cannot have one init args.
Jeez. Jeez.
What I want to know is why Klaus didn't scream at you for doing that.
That's why I'm amazed. It did not. It compiled, and I was like, okay.
I mean, like with an alternative meta class that you know you can define custom slot properties like that, but that's a standard object.
What? Hold on, I have a typo somewhere. Where are you? Oh, that's the path. It doesn't like what?
V. The verisimilitude.
That opens up a new buffer on the bottom. That was very helpful.
Yeah.
Just go back to your original file there, and you might have a typo in the reader macro for the path name. I don't know what's going on because it thinks you actually typed P rather than #P.
Okay, let's go back to. Let me kill this buffer here, and go back to main.
Wait, you did type #P in your REPL. So what's going on?
#P.
Where is it getting P from?
I have no idea.
Let's look at that stack again. That's kind of weird.
Let's go to that.
Read flash stream, and it's okay. It is. It is getting a stream on
Let's look at the definition of the width buffer macro.
Look at the definition of the width buffer macro. All right. Go back to buffer. The width buffer macro.
Yep, there's an extra P in there.
Oh, there is.
Last line. Start of last line.
Oh, dang it. How did that happen?
Who knows?
All right. Third time's the charm. What?
Compile. You redefined the macro, but you didn't recompile the code using it.
Oh, thank you.
Yeah, anywhere there's a width buffer, recompile that. It's just one right now.
Also, that's probably why compiling that width buffer was getting you an underscore. No warning.
Invalid initialization argument.
You probably did an args on that class too.
Yes, I did.
You did.
Thank you.
I mean, we didn't see it this time either, so like, it's not just on you.
I swear. I just need to remember it's init arg. All right, which means I have to do this one more time. And
actually, not in that case. You didn't need to, but don't hurt.
Read string only doesn't actually write anything out.
Yeah, well, you printed it, so it's fine.
Yeah, but
call that again. Oh, I did not see that. Okay.
Mm-hmm.
It gave me a new line. Should have read 4 bytes out of that path.
Okay. Try get rid of the read string and just read I don't know, 8 or 16 bytes or something. See if you're getting actual bytes or all zeros or whatever.
Okay.
$102.76.
That looks right. Yeah, 102.76.97.67.
What is 102? What character is 102?
97 is A.
97 is A. That I remember.
Okay, so that should be F then.
Yeah.
And that's in the right range to be F.
F 76 is capital L.
Yep. Which is
What happens if you just return read from string or read string in that function instead of metadata? Is it?
I hope that doesn't fix it, but
That
sure,
shouldn't
let's
fix
check.
it, but I mean,
Yeah,
I'm
yeah,
trying
no,
to-
like let's narrow things down. I agree.
that should not fix it. I'm starting with the simplest first.
Yeah, and remove the remove, yeah.
Oh,
What?
oh, that could be what you did wrong. I think before you didn't do byte count.
I did do byte count, I thought. Let me see.
So,
Yeah,
Yeah,
I did byte count.
oh, wait, yeah, that would have failed anyway. Okay, forget it.
So, let's see here. Yeah, you wanted me to get rid of this guy.
Yeah, just get rid of that.
Okay, there's something wrong with read string. Give me a second. I'm going to pull up.
No, I think it's all fine. I think, you see, what we want to do is,
well,
like, see, we have to call with buffer on basically a sequence. Basically, okay, so here's how it's going to work to test this. Create a little temporary function called like parse magic string or something like that, because that's what it's called. It's called the magic number or the magic string. That's what they're usually called at the top of a file.
Okay.
Or the marker. Called various things, but yeah, just make a little temp. Well, we'll probably copy this to another file later, but we have to we have to do a certain series of steps here.
Okay.
And it's probably best to put that in its own function because we'll probably copy it to another file later.
Okay, so defun parse magic string. Okay, and I'm assuming we could just grab it from the stream.
That's that won't take any arguments.
Okay, and it will go.
And then do with buffer, yeah, inside that. And instead of stream, pass the keyword sequence. And the argument to that is going to be read bytes 4.
Okay.
And then inside that, we can read a string, basically, read string. Yeah, the way we set it up is we need a buffer of bytes to read from.
Ah. Okay. Let's see this. Parse magic string instead of this guy.
I'm pretty sure that's the issue anyway.
Did I compile that? Yeah, I did. Boom. Okay.
Hooray.
That makes me happy because earlier I was like, why is read bytes working? This should have worked before.
Alright, we're probably going to be working with both like a new file and this file, so do you want to open up another
That's what I'm doing. I guess.
with a new file called like data stream or something like that. Or block stream. Block dash stream. Because we're going to have a few different blocks.
Got it.
Actually, I think there's only 2 blocks, but then there's different types of the second block.
Okay. I'm just going to stick this all in this package for my sanity.
If I remember correctly anyway, it's been a while.
Okay. And I'm going to go ahead and move this guy over here. That's too big. That's fine.
Okay,
so if we look at the specifications,
concern there is that you're presumably going to be loading blockstream after main because it relies on the package that you define in main.lisp. but you're calling a function in Blockstream from main, and that introduces a cyclic dependency between those two files. And so you're going to get compilation warnings. Because when you load in main, parse magic string won't be defined yet, and you can't load in Blockstream until you've defined in main because it needs the package definition that's in main.
Right.
Yes.
Also,
Okay.
do you have, is with buffer defined in the same package? Just checking.
No, with buffer is defined in a different package altogether.
Okay, then you have to create nicknames for them and
Yeah, I did.
qualify them correctly. I mean, in your new file there.
Oh. Dang it. All right. Give me a second here. I'm going to do some... This is a dirty hack, but this will work. I'm going to define the package here for now, and then I will, in my ASD file, order it and say that it's a serial loading.
Or you could introduce an interfile dependency.
Yeah.
Serial's easier. So that module's already serial. No.lisp.
Oh, thank you. All right. Let me just do a quick load here just to make sure I didn't blow it, do anything crazy. Demo. Okay, we're good. And we're back. Okay.
Okay. So read FlexStream should do what we were doing earlier and call parse stream.
Got it.
And it's parse stream that's actually going to call parse magic string. It's going to do a few more things because the block has 4 different fields in it.
Okay.
I'll have a sudden urge to get back to working on my persistent trees.
You have an urge to go do what now?
Oh, remember his tree library he was talking about?
Oh, yes.
Yeah, that thing is pretty cool.
Yeah, it is.
It's still making progress, slow but steady progress.
Okay, so parse stream. Well, the first thing that's going to do is it's probably going to create an instance to store the state that it parses. So we have to create a new class for the stream. Call it like block stream or data stream or something like that.
Block stream is fine. Okay.
And this is basically your concrete syntax tree. Basically wants to be as close as the language permits to the actual specification.
Right.
So the first one is called the first slot would be called the
Metadata
marker,
block,
or the stream marker they call it. I usually just call them marker because they're all called the marker for various file formats just about.
Wait, I'm sorry. The according to the stream, the top level stream, it
says the FLAC stream marker in ASCII. That's the description.
Okay, got it.
It's the stream marker or whatever you want to call it there.
Arg marker. This time I'm using it at arg, as you guys can see. Okay, and I guess we'll just say stream marker just for consistency. Stream marker here. All right. Then you have a metadata block, which is the mandatory stream info block. So
call that stream info.
Stream info. Arg stream.
Or stream info block. It doesn't matter. You don't have to be too descriptive here.
Yeah.
I'm not going to have many ambiguities.
And this is also a reader because we're not modifying this. Stream info. Okay.
And then another one for the remainder metadata blocks.
So I guess blocks, I guess I could call it, or metadata.
Metadata blocks, because you got to differentiate between the other types of blocks.
Right.
Which are the stream that we're currently parsing as well as frames.
And since there's 0 or more, I guess this could be an init form. Start it out as empty, and then make this an accessor that we're going to be messing with. Call it metadata, I guess.
Yep, and the last slot you could probably leave off since we're not going to be parsing frames, but you could add it for completion if you want.
Okay, I'll add it for completion. That way, if I go crazy and decide to go and figure out how audio libraries work in Lisp, I can go and do that.
Yeah, see you in a few years. That can be pretty complex, let me tell you. You got to deal with like Rice encodings and Huffman encodings and all that jazz.
Okay. And this is 1 or more, so I'm just going to create this as part of the frame. Alright.
Alright, that's all we need for our class.
Alright. Cool.
So, yeah, the first thing ParseStream is going to do is it's going to create an instance of that class. Without you don't need any init args on that. Because we're not actually going to fill them in right there. We're going to call our readers at various points, like probably inside destructuring bind and stuff like that. So.
Okay, so if that's the case, then we're going to populate this later. Let me go ahead and make these then into accessors then too. That way.
Yep, good call.
Alright.
You can get rid of the init arg on those just to make it shorter and, not imply that they're actually being passed into the instance arg make instance call.
Right.
Because they're not going to be ever. You left one there for frames. Oh, well, that's alright, I guess.
Oh, yeah, that's true. I'm going to go ahead and delete that guy. And make this into an accessor too. Folks, this is just a fancy way of creating a struct. Should have just went with a struct.
Yeah, it's a very fancy to do a struct, but yes.
Make instance, block stream. Okay. And
yeah. And the first thing we want to do is we already tested our marker is correct, so we want to set f the marker accessor to be our parse magic string function. And like later, we should add some handlers and catch some bad files and stuff like that. But
oh, you mean like a handler bind or something like that too?
Yeah, something like that.
Okay. All right.
Proper conditions.
Okay, we could go full
yeah,
with this later on.
That's just a lot of boilerplate for no real benefit at this point since we know our FLAC file is correct.
Right.
That's something that can always be added later. Okay, so we set the marker. And the next thing on the spec is a mandatory stream info metadata block.
Right, so let's go ahead and do that.
As well as 0 or more other metadata blocks. So we kind of want a new file for metadata, block metadata.
Okay.
Where we will define a class for them.
All right. Flag. No. I'll just call it metadata. That was for the time being. And I'll set this up later. Flag metadata demo. Okay. Actually, again, I need to. And we have our class that we call metadata. And this guy holds...
So all metadata blocks, they just have 2 slots. Right. The header and the data.
The header, which I'll just call metadata. Header.
And believe it or not, the header is another class.
Yes, it is. I know. Hold on.
Well, you could shove them all into that if you wanted to, but I think it's a really good idea to model your CST like the spec.
Right. Absolutely. Def class metadata header.
Now your AST, on the other hand, that can be completely up to you.
AST would only work if we want to restrict ourselves to a particular derivation, right?
Yeah.
We can. Right now, I don't think we need to even worry about that.
Like normally, you would parse the CST exactly as specified.
Right.
Without even like type checking or various compiler phases, and then you would iterate on that and compute your AST with proper type checking and modifying the tree.
Right.
But in the sake of simplicity,
since we're just parsing a binary file that's kind of well defined, I don't think there would be ambiguity. You wouldn't have to worry about that. Anyway, so
where are we here? So the header
would hold.
Okay, so the header has 3 different slots on it, according to the spec.
Right. So
it has a flag for like last metadata block flag. I would just call it last flag or whatever. Yeah, it's just a flag specifying if it's the last metadata block in the flag file.
Right. So this guy is...
That's a Boolean value. Well, it'll be 0 or 1 in the CST, I guess, but we could parse that out as a Boolean. That really doesn't make sense.
Do you want to specify the type here or something and say that it's a Boolean? I don't think that's necessary.
No, you don't need to.
Okay.
That's just extra. We could add all that later for documentation purposes. Right.
And then we have the block type. So I'll
block type.
Let's call that type.
You can't edit type. You can't make it type. You can make the slot name type, but you can't make the reader or the accessor name type because that's an actual function in CL.
Right.
Without shadowing it anyway.
And that's the reason why I called it block type for now.
Okay, I wasn't watching your buffer. I'm looking at the spec.
And then
and the length flag, which is the same deal. You can't name it length.
The slot can be named length, though, right?
So yeah, I would just call it block type and block length.
Okay.
Cool.
Right. So now we have the data block. And the data block.
Let me think about that one for a second.
So while you're thinking about it, I just want to ask, because when I read this originally, it looked like metadata block data was a union. I mean, I'm talking about in C terms here.
That's partially why I'm trying to think about this. Just give me 1 second, actually.
Okay.
Let me look at my library to see how I did it. I haven't pulled that up yet. Okay. Yeah, I would hold off on defining a class for that, because basically each block will have its own class, each block type.
Yeah, that's what I thought. The stream.
There's no commonality in between them because we separated out the header section. So
right.
that would be your superclass, and if we were doing this like as anything else.
If we started leveraging inheritance, we would totally do that. But I do favor composition, so I'm okay with that.
Which I don't really like the idea of the header being a superclass because it's really not, conceptually speaking.
Right, exactly. I agree.
Okay, so where were we, back a few files. Weren't we in like parse data stream or something like that?
Yeah.
I forgot.
We are, so this is now defined, so let's go back to block stream, and here is our stream marker data.
Okay, let's make a small correction.
Okay.
In your parse marker function, or whatever you called it.
Parse okay, got it. Parse magic string, yeah.
This, the whole file is going to fail if it's not a valid FLAC file. So rather than, possibly corrupting memory or whatever, I would let bind the read string call, and then do, if string equals marker FLAC, then just return the marker. Otherwise, throw up an error and never continue.
Okay.
Because, we don't want to pretend that it was FLAC and then try to read something else.
Got it.
We just have a bunch of garbage in our memory.
1 second.
Slightly better than a condition, but enough to make it so we don't possibly blow our heap even.
Right. Okay. Call this guy marker for the sake of if I guess I'll say when. I'll just go ahead and say when string equals marker FLAC.
By the way, you don't even have to pass byte count there, because that covers the third case for read string that we handled. Oh. Since our sequence is 4 bytes, it's going to read until the end of that sequence anyway.
Okay, got it. Cool. We don't have a default, though. That key looks like it's required from what I'm reading in my...
Nope, it's not.
Okay.
All key arguments are optional.
Okay, so when
we handled that case especially. No, do an if there.
An if? Oh, so you want to have an else condition? Okay.
Yeah, nothing changes except it's an if, and then the last branch of that if will be an error call.
Got it. Error.
Not a valid FLAC file.
Invalid FLAC file passed. All right. Got it.
Cool. Okay. So the only other thing we need for parse data stream is to actually parse the blocks. Okay. So if you notice in the spec, the next two fields are a stream info metadata block, which is mandatory, and 0 or more extra metadata blocks.
Right. So we need to do first...
So in our parse stream, no, I would actually not do that. Make it a little bit easier for you. After the setf,
okay,
you can do destructuring bind.
Oh, got it.
And stream info. Either and rest or dot. They both do the same thing.
Okay.
And then metadata blocks. No, no, not in another list.
Yeah, got it.
Yep, right after and rest.
Metadata blocks, got it.
Yep, and that is like after that binding list. you want to make a call to whatever we're going to call our metadata block parsing function in the other file that we haven't written yet.
Yeah, so we're going to have to call this parse metadata. You know what? I'll just call it parse metadata. Just because I can't think of anything right now.
Yep, which is going to be a function that returns a mandatory stream object or stream block,
right?
As well as possibly nil or more metadata blocks, and that destructuring bind will just parse them all out.
Once we do that, then
then within that we just set f everything.
Got it. Stream info, flag data.
It's going to be stream info, exactly. Yep.
And
metadata blocks. It's going to be metadata blocks, exactly. And frames is going to be nil, I guess.
Yeah, frames is going to be nil. Flag data. Metadata. And then frames of it is going to be nil since we're not actually.
Yep, so that leaves us with that dependency we have yet to be defined, parse metadata.
Right. And parse metadata is going to be, I think, going to be defined in here.
And this is the meat of the application, so it is pretty complex, but not too complex. Parse metadata block. Do we have a metadata block class yet?
No, we do not. We have to go and define that.
Oh, yeah, we do. Metadata.
Oh. No. Oh, yeah.
That's the one with header and data, right?
Yeah. Mm-hmm.
Yep.
That's right. Never mind.
Okay.
Parse metadata. Let's go for it.
In our parse metadata block function, or parse metadata, I guess you called it.
Yeah, I can call them parse metadata block to make
things.
It
doesn't matter.
Okay.
So basically what we want to do here is just, first we want to set, well, let me think. So, one second, because we got to deal with the header especially.
Right.
So, yeah, I would let bind, metadata block and make it an instance of metadata.
Okay.
Yeah, and then we can set f the header to be, well, actually,
I mean, that's what I thought we would do, because that's pretty simple, right? Because since the metadata header is, we have just three reads. We could write a parse metadata block header and just read that out of the stream.
Yeah, I'm just checking to see how I did it really quick.
Got it. Take your time. Folks on the stream, are there any questions so far as to what we're trying to do, or?
I can't remember how I set the header. I'm not able to read my own code at the moment, so let's do the obvious and just make an instance of that too and set it.
Got it. Do you want me to do that in the same function, or?
Yeah.
Okay.
Yeah.
Metadata.
Yeah. Why not?
Block header. Make instance.
Just call it header and bind it above metadata block and make it a let star. Then you can just pass it as an init arg if you really wanted to. Save you from all the set Fs.
Yeah, that's probably going to make things cleaner too. Sorry. Let star header make instance.
Quote metadata header. And then just do colon header header in the second line there. Yep, that'll set it up. And
hold on, forgot that. Now we have it. All right.
Yep. So after that, we just want to go ahead and start setting slots of the header. So
right.
I'm looking at this back here. The first flag of the header is the last flag, which is exactly 1 bit long.
Right.
So we would just call read bits 1.
Read bits. Sorry.
For that one.
Okay. Did that, and then the next one is 7 bits for the block type. It looks like.
The next one is that's for the type.
So block type header read bits 7.
The next one is
block length.
Okay, this is actually an integer. And FLAC, all of its slots, all of its fields are in big endian form. So this would be whatever we called our integer big endian function.
So this is an integer?
Yep, it's a length.
It says, though, that it's 24 bits here.
It is 24 bits, which is 3 bytes.
3 bytes.
So we read an integer worth of 3 bytes, or 3 bytes worth of an integer.
Oh, okay, got it.
In big endian format.
Uint b byte count is 24 bits, 3 bytes. Okay. I was just thinking integer 4 bytes, and I'm just like, that's.
Okay, at this point we should probably try to see if we can get something compiling without warnings and run our function again.
Right.
Hold on. Before you do that, return metadata block from that function.
Got it. That's what I. Metadata block. Okay. Cool.
Now everywhere that calls that up all the way back up the chain, make sure it's all up to date and compiled without warnings.
Okay, so that's loaded. That's okay. Everything's up.
Try to run it. Invalid number of arguments for parse stream. How did we devolve into that? I thought that was working.
that is odd. Hold on. Let's go. Oh, parse stream isn't taking any arguments. So that means in our function. Oh, I'm passing in the stream. That's wrong.
Oh yeah, no need to do that. It's all dynamic binding in our buffer.
Okay. Okay.
Oh,
so,
we don't have an init arg up in metadata there for header. The one case we need it.
The one case where I had it right there. Oh, jeez. Okay. Header.
That should do it. Nope. Invalid number of... Oh, okay.
Yeah,
so
that's fine. That's right.
For now, just return a list instead of metadata block, just as a temporary hack.
With that.
Just do list metadata block as the return value.
I was just going to use values and then pass in a nil, but that's okay. All right. I don't have to recompile anything again, do I? I don't think so.
No.
Okay.
Should be good. We never returned our thing from our read stream function. Up there, after you set F, you want to return FLAC metadata.
No, we did. It's just that we deleted it.
All right.
We just didn't add it back. Sorry.
Now, click on that and inspect it. So we have our file path and our... Oh, we're not setting the parse tree. Why?
I think we forgot to.
Okay. Let's see what we did wrong.
Okay. Yeah.
Set of parse tree, parse stream. What does parse stream return? Probably no. Did we forget to... Where is parse stream defined?
It's in block stream. Give me a second. Yeah, we're not passing. We're not returning here.
Yeah, we gotta return the block stream class instance FLAC data. Yeah, try inspecting that guy now.
Wouldn't I have to rerun that?
Yeah, you have to recall it.
Recall it?
Yeah, rerun it.
Oh, okay. That's what I've done. Okay. There we go. Parse.
All right, click on parse stream, or the block stream, and see what it says. Make sure everything is correct.
Black.
So frames would be nil. The marker is correct.
Blocks
we have no extra blocks, but we do have a stream info. Let's click on that guy.
The metadata
data we
header.
haven't parsed yet. The header. Let's click on that guy. So it's not the last. We know there's metadata blocks in there.
Right.
And its type is 0, which is correct, I believe.
Correct means that it's not the last one, right? Yeah. 0
but
is...
For type, no. Oh, which one are you talking about?
Oh,
last
never
is
mind.
0.
Last is 0. It's not the last block. Type is stream info. That's right.
Yep. So that's all correct. 34 should always be the case for stream info. 24 plus 7 plus 1. Yep.
34.
Wait, no. Plus the header.
Oh, what?
Or that is the header plus the data.
Okay.
I think. Wait.
It should be 32.
Length and bytes of the metadata to follow. Oh, okay. So 8. Yeah. 2, 4, 7.
This is not the metadata block header length. This is the length of the metadata block data.
You wanna verify this, and your rep will just do plus, and we'll add all these together and divide it by 8.
Okay. Give me a second. Okay.
Just to make sure we didn't parse anything incorrectly.
24, 7, 1. That's the header.
No. We're doing the stream info data section. So it's 16, 16,
16,
24,
16.
24.
Oh, got it. Never mind. We'll go on that. All right. I see that. 16, 16, 24, 24. That's 48, 20, 68. Oops, sorry,
Got
20,
yeah.
3, 5, 36, 128.
Divided by 8.
All right. Yep.
Perfect.
Okay, cool.
Our length is correct.
That is right.
That'll always be the case for stream info. 34.
All right. Cool.
Some are variable, but not stream info.
So success. So we got the stream info header going. Now we need to actually get started on the meat.
The body, the data section of stream info. And then after that, we can worry about the extra metadata blocks because there's a lot of nonsense involved in figuring out their type and calling the right function and everything like that.
Well, I just got to ask. I mean, there isn't like even a concept of unions, is there? I mean, like you can't.
Concept of what now?
No, there isn't a. I mean, we have def struct and we have def class, but we don't have anything that could mimic or a union, right? So we'd have to design this a little bit for the metadata block data.
Well, we don't. I don't know what you mean by union here because, like, really it's just composition. We're just gonna basically create a class for each type of metadata block.
That's right.
And stick it in the data section as an instance of that.
Oh, that's because it can
hold the heterogeneous. Composition here.
Right. Okay.
Real inheritance or unioning or anything like that.
Right.
We have RTTI. We have no need for unions.
Right. That's what I keep forgetting. I have C on the brain, so I'm trying to.
Yeah, no, this is not me, my friend.
I'm trying to unlearn that for when I'm coding in this. So
everything works up to this point. Probably be a good point to save everything, reload, and make sure it still works, and then make a commit, just so we don't screw anything up in the meantime.
Right. Okay.
Yeah,
and we got a few minutes left to probably just finish up the stream info data section.
Yeah.
Call it a day.
Second.
I mean, I'm up for going longer if you guys want to, but it's almost that time.
Yeah. Let me just double check to make sure.
Yeah. I would definitely restart your image though, just to make sure your loading is correct.
Yeah, that means I have to actually first. I think I'm missing a few things in my ASD file.
Fair enough.
I do not.
Can you guys still hear me?
Yes, I can.
Yeah, you're very low though.
Apologies. I can fix that. Actually, did moving my mic just then help at all?
Yes, it did.
Okay, yeah, because what I've been doing is I've had my mic out of position specifically so I'm not breathing into it. Like so.
Just making sure everything's good. Okay, this should be fine. Let's go ahead and fire this up. Sayonara. No, actually, it's restart Lisp.
But I can instead just increase the volume of the microphone.
It sounds like you're trying not to wake your neighbor or your roommate or whatever. It sounds like you're like talking as low as you can without a whisper.
How about
me anyway? Yeah, that's good.
Okay, good.
Okay, set package, metadata demo. Go ahead and do the read flag file again. With their path.
You can just push pop. I'm sure it's still in your history.
Oh, that's also a good idea. Read flag file.
Or, yeah, it's not up with the default bindings. I think it's like control up or something like that.
Control. It's
I
meta.
forget what it is.
It's meta P, but I think I just do reverse search because we actually have read line here, so Control R would work just fine. Okay, so block stream works. Looks like we're back, and
yeah, just make sure we got our header section filled in correctly. Cool, we're good.
We're good.
That's where we left off.
So let me go ahead and check
so
this
guy. All we
guy
have to do is the data section for that guy.
Let me go ahead and check this guy in.
Yep.
Local host, local projects. And make sure that I don't have any of those temporary buffer files that Emacs tends to write out. Git add. Completed person information. For folks who are watching the stream, I'm checking in stuff in a different in my terminal outside of Emacs. So, all right.
Okay, so
let's go.
Close that inspector. Let me see that other file underneath it. The parse data stream or whatever.
Oh,
the file with parse stream in it.
Oh yeah. The block stream. Sorry, that's in this file. There.
Oh, but I also wanted the block file next to it.
Okay.
I just want to make sure everything's set up how I expect. Okay, so, metadata blocks. Okay, so, after we set up the length there, we also need to set up the data. And the data is on the root metadata object, not the header.
Okay, I really did a terrible thing here because I have my let bind being named metadata block and the accessor is called metadata block. So.
I would make a small change when you're done with that.
Okay. And
I would rename the metadata class to metadata block and rename your parse metadata function to parse metadata block.
Got it.
And then we'll just call the actual data parser parse metadata. And make sure you make an instance of the metadata block now instead of metadata.
Okay, hold on, let me just compile all this here. This is done.
Yep.
And this is metadata block now. Give me a second. I hate this word wrapping crap that's happening. Okay. And this is now going to be called metadata block data, just so that it matches now the specification, so to speak.
Okay. Now I would make, so basically what we're going to do is we're going to call parse metadata. We don't want to make a case here and figure out the block type right here because that would be kind of messy.
Right.
So parse metadata could actually be a generic function that dispatches on the type of block.
Ooh, yes.
So let's make a def generic called parse metadata. And I believe that could just take a single argument called like block type, and it'll be a symbol, probably a keyword symbol or something. I didn't mean at key like that. I just meant, just a single argument.
Oh, okay.
Makes no sense to do that. Yeah.
I was just like, what? Okay, hold on. Generic function to parse different.
Yep. So the one thing all block types will have in common is they all need a class and they all need a method on that generic function. Right. So we can write a very trivial macro to do that.
Give me a second. What I'm going to probably have to do is restart my image because we had that old function there, and so...
Oh, that's fine. Just compile the def generic and tell it to override it if it exists. Yep.
0.
Replace. Yep.
Okay, got it. Okay. All right.
So yeah, the one thing they all have in common is they all need a class to store all their state while parsing, and they all need a method defined for that parse metadata generic function.
Right.
So we can write a macro to do that for us, a really simple macro.
Okay.
Let's just call it, and inside this we could basically abstract it away. So the body of this macro will just be a setf form. So we don't have to have all the boilerplate for setting up the buffer and everything like that and setting slots.
Right, right.
So it'll be a pretty simple macro. We could, let's just call it like define metadata.
Yeah.
Or define block, or define metadata block, I guess.
That's fine. I think that makes sense because it matches what we're trying to do. Or metadata block data, I guess. Just to match what the specification calls it, so they know what it is.
Yep.
And it takes in...
Let me see how I did this, because I did something similar, I think. Yeah, okay, I did. Make a nested list there, another parenthesis.
Oh, got it. Okay.
And block type, or type, doesn't matter.
Okay.
Okay, close off that inner list there. And I really don't want to get into mop territory here, so we're going to make this a little simpler. Let's do another list. And do and rest selects. And close off that list. And then do and body. No list.
Right. Cool.
Yep.
Okay. So since we have with gensim, I guess.
Yeah, you're gonna want to with gensim a couple things here, actually. Yep. Type and that would be the symbol. Type and call it metadata.
Type and metadata. Okay.
Yeah, that's good. Okay, so this body is going to be basically expanding to a def class and a def method.
Got it.
So
that's
we
right.
have to put a prog in there with a backtick around that. And, you know, the first one's going to be def class.
Def class, and I guess this is going to be the comma metadata type, right?
No, actually. Well, I would do one small change, actually, or like above your prog n, do a let. Yeah, without the backtick, yep. And call it like class name, I guess. And then call Alexandria symbolicate.
Ah, okay.
So we can actually basically namespace all of our classes to be metadata dash whatever.
Got it. So we'd want to
So
do
we'll just concatenate no, you don't want to do that. That'll be a lowercase symbol, which is not what you expect. Just do the symbol metadata. You could probably actually even do quote hash.
Quote hash?
Yep, colon. Metadata. Metadata dash, actually. That's an uninterned symbol. It'll just make it so this partial symbol doesn't actually get interned to any package.
Got it,
which is kind of useless. And then, you know, block type.
Okay.
So that'll be the name of our class, and then our def class will be comma class name.
Got it. And then this is probably not subclassing anything anyway. So.
Nope, just an empty list there, and then comma slots.
Comma slots or comma at slots?
Comma slots.
Yeah, that's right. It has to be a list. Never mind.
And that's good for the def class. And then a def method.
Parse metadata.
Oh, you don't want a space there. This is all the same macro.
Oh. Okay.
And that's going to specialize on the block type. So our actually.
So block type.
Okay. So no. Sorry. It's going to specialize on a gensim because we don't need to expose that. So our type there that we gensimmed, just do get rid of the block type and do comma type. No, you still want the 2 parentheses. It's a specialization.
Yeah, that's right. Sorry.
Yep. And
close parentheses.
And then it's going to be EQL.
So.
And that could either be. It depends. Like, I would make it a keyword symbol. So I would do. Well, after comma type, there do EQL.
EQL.
Well, as a call, it's a function.
Oh, that's right. Sorry.
And then a call to Alexandria, make keyword.
Name.
Actually, put a comma in front of make keyword. So that is expanded at compile time.
Right. Okay.
And that's going to be your block type. Yep. And the body of that def method.
Okay. So
all it's going to do is it's going to do our idiom that we've been repeating a few places, which is let bind.
Wait, did I need a nested list there though? Because the generic function doesn't have a nested list.
That's because your generic function can't specialize. It's the protocol.
Okay, never mind. Okay, I'm with you. All right.
Does that make sense?
Right. No, that's right. It's a the generic signature is not starting the tables, whereas here you're specializing on it. And
okay. So if you have any questions, just please let me know. Yeah. I don't want to just talk and have you type in random nonsense that doesn't make any sense to anybody.
Right. No, this is why I'm asking this question, just to make sure, because we have in the defined metadata block data macro, the specialization on block type. I mean, this nested list with block type, and I was just kind of curious where this kind of falls into that. So.
Yep, that's just the specialization. So it's basically going to expand to a def method with the type equal to, and then that keyword symbol is going to be inlined into the code.
Got it.
For the block type that you pass into this macro.
Got it. Okay.
So the body of your def method is just going to be what we've been doing for just about every function so far. It's going to start off with a let binding. Right. Which makes an instance. So let comma metadata, our other gensim. Well, 2 parentheses first. Let that equal make instance of our quote comma class symbol, or whatever we called it, class type, class name. Yep. And 1 more parentheses, and then inside that let binding. Missing a parenthesis, actually.
Oh, sorry. Okay, got it.
And then inside that, so we don't have to work around with the mop. Let's just do with slots.
With slots.
Comma slots. Comma metadata.
Right, so we're grabbing the slots for the instance. Okay.
Yep, and then we're just going to do with buffer, which is probably in another package if I'm not mistaken.
It is.
We do have to qualify that then.
Actually, I think in you don't have to qualify it because I think I use it. Yeah, I use it. Never mind. You're good. This is not a good idea. Generally, I do like doing the package.
Yeah, at that point, it's like, why are you using separate packages?
Yeah, exactly. But right now, I wanted to at least get it all working before I clean it all up a little bit more. We could do that as a separate exercise later on.
Yep. So with buffer, it's gonna do your same thing with the. It's gonna. We only do stream when we're opening up the file stream at the beginning. Everything else is gonna be the keyword symbol sequence because we actually want to create a buffer. So sequence is gonna equal read bytes.
And the byte count should be the
byte count is actually going to be the length of the header of, I noticed a bug in our program so far.
Okay.
Really quick, this will take 2 seconds. In our block file, the one on the right, go up to the top. After the def package, or after the file, it doesn't matter, somewhere inside the package. Yeah, make a def var. Metadata block with yeah. Okay, we need this to be a special as well. And down in your parse stream file, I think in the parse stream. No, wait, why is parse? I'm trying to understand your code first. What is parse? Oh, this is block stream. I meant in the metadata file. Put that def var.
Oh,
I'm sorry. I thought we were in that file. Just delete that.
Okay. Hold on.
Delete the def var. Put it in the other file.
Got it. We were in the metadata file. Def var.
Oh, we were. Okay, I'm sorry.
Metadata block. Okay.
Yep.
All right. And in the parse metadata.
Yeah, in the parse metadata, just change that. Making an instance of the metadata block class, change that to special rather than lexical.
Okay.
And oh wait, no, not in that function. Up 3 top level forms in your big function.
Okay, let me see here. Parse metadata. Oh.
Yeah, metadata block. Change that to metadata block with earmuffs. And anywhere it's used for the rest of that function, change that as well.
It's only being used here. Just double checking. Yeah, that's fine. And then we're returning this, so we need to go and return the def var. Okay. Let's start. What is the warning? Parse metadata is called with 0 arguments, but wants exactly 1. So we are not passing in something to parse metadata from this. I'm guessing the block type should be what's passed in from the header.
That No. Let's ignore that for 2 seconds. That's a really simple fix, but let's go back to what we were working on.
Got it. Okay. We read bytes.
Read bytes is going to be the length of the header of our special metadata block.
Got it. So let me just go.
Well, I don't know what you called it. Is it like block length? Or, yeah, the block length of our header of our earmuff metadata block.
Got it. Okay.
So that'll create a new buffer on the stack of bindings equal to whatever the length of that block is.
Right.
Okay. And then after that, we just do comma at body inside that with buffer. Yep. But we want to return comma metadata at the end of that let binding, basically.
Metadata. All right. Parse metadata.
Yep. Make sure they're all closed and compile that. That's done. And I'll show you how this is used in 1 second. Let's go and I think we can fix that problem you found.
Okay.
Okay, so when we parse out the header of a block, the type field is going to be an integer representing that type. But we want a keyword symbol to pass the parse metadata. So we just need a simple case dispatch on the number mapping to a keyword symbol of that type. So we just need a really simple function that, lists the 5 or 6 different types as keyword symbols.
Okay. Let's call it defun metadata block type that takes in the code, I guess, and we do a case statement, I guess, would work here.
Well, actually, it actually doesn't need to take in anything.
Okay.
Because we have access to that special anywhere in that scope. So it would just be case.
Keyform should be on the
block type.
The block type, thank you. Block type
of the header of the metadata block. Nope. Yep, do the header.
That's the header.
We called that metadata header. Okay. Sorry.
Yeah. I should have. I mean, I've been. There was.
Perfect.
Okay. And
the body of that is just going to be a bunch of integers. So the first one is 0, which is the keyword stream info.
Okay.
Keyword.
Sorry, stream info.
Yep. Looking at the spec. 1 sec.
The
next one is 1.
Padding.
Well, they go 1 to 6, or 0 to 6.
To application free seek table. This is just for code that I'm mindlessly just copying. Warvis comment, which I don't think we're ever going to touch.
You have an underscore there.
Oops. That should be. Thank you. 5. Cue sheet. 6 is the picture. And then that's it for now.
You do want to, the spec mentions that 127 is invalid,
Okay.
and 7 through 126 is basically going to be your otherwise clause. So after 127, you can do otherwise.
Otherwise,
Reserved, it's called. That'll just make pipe checking easier later because we can check those keywords.
Is it otherwise or is it true? Is it T?
It could be either one.
Yeah. T reserve.
Yep.
Okay.
So 7 to 126 is reserved by the future versions of the spec, basically.
Why the heck is that not defined? Okay.
So now we can call it for our data section, our setup there at the bottom. We can call parse metadata and then whatever that function is.
Type. But what do we pass? Oh, we don't have to pass in anything. Cool. Okay.
Wait. Let me think here. Metadata block of your metadata block equals parse metadata block. Yeah, that looks right.
No, that's right. I just wanted to.
All right. Compile that.
Looks like no errors.
Okay, and our macro there, that works now. We could write the really simple stream info. Like this is literally just set effing stuff. We don't have to do any more real boilerplate now that we have that macro.
Right.
So we can actually call define metadata block
on the type.
In parentheses do stream info.
Like that. Okay.
We don't have to actually use a keyword symbol there. I mean, you can if you want, but we're calling make keyword inside the macro, so it's automatically going to be. Actually, we don't want to because we're making a class that doesn't want to be a keyword symbol. So just stream info as a regular symbol.
Okay.
Yep. And then after that list, we want to specify all the fields of the stream info data section, the names of those fields. So if you look at the spec, the first one is minimum block size.
Yeah, minimum block.
That has to be in a list, though. This is a list of all the slats.
Hold on, let me just
this is just so we don't have to do some mop nonsense. That would be a ton of code just to get rid of this.
Min block size.
Yep. Max block size.
Max block size.
Min frame size. Max frame size. Sample rate.
And bit number of channels.
Channel count or whatever.
Yeah, channel count will probably be fine. The bits per sample.
Bits per sample. Sample count.
Sample count.
And the MD5.
Yes, MD5. All right.
All right, and then our body starts after that list of slots.
Right. I don't have to program these, right?
No.
Okay, cool.
We are in the expansion is a let binding, so it's basically going to be a whole body of code anyway.
Okay, set min block size to be the read. That's 16. That's that in bits. 16 bits, 2 bytes. Read bytes. 2 max blocks.
No. Now when we're reading the spec, we have to look carefully at what the implied type is. We see it says 16 bits, which is 2 bytes, but
it's an unsigned.
It's an unsigned big integer, or not big integer, big endian integer.
UINT B. Okay, fine. So
basically, like, we don't want bytes here because this is just going to be a count of however many samples there are. We'll be able to display this to the user as an integer.
Everything in this packet is big endian, isn't it? Or is there
everything is big endian in the FLAC spec. However, there is one metadata block type for storing ogverbis comment data, which is how tags are stored.
Right.
And that is another format inside of this format, and that all uses little endian.
Jason, you have some hesitation there.
No, I was just saying, that's why we originally wrote both versions.
Yes.
And they were both trivial anyway, so no harm done.
All right. Okay, so then 24 bits. That's
these are going to
be...
the first 4 there are going to be integers because they're dealing with, the count of frames in blocks. So.
Read uint e.
Yep, 3.
Uint e. And then we are at the sample rate. Sample rate is 20. It's between. That's an integer, isn't it?
Look carefully. It is an integer, but we do not have a bit reading integer function. We could just literally read bits.
Right.
And that we already told that to return an integer, I believe, when we wrote that.
Read bits? Yeah, I think we did.
Yeah.
Let me go and pull that up. Okay, you guys are going to see some crazy number of buffers going on right now, but this is
that's fine.
I tend to work.
This is actually on the very same side compared to my Emacs. Read bits is in the primitives file, I think.
Yes, that's right. Wrong file. Read primitives. Okay. Is the return type of read bits from bit IO an integer? It should be, right? Yeah, I think so.
Yeah, it should be.
Okay. So
I mean, it can't be an octet vector, because that would make no sense. It would have to be multiple values returned if it was.
Okay, so now we have a channel count, which is from 1 to 8. That can be just what we did before. That's 3 bits.
Yeah, so basically whenever a field is not divisible by 8, we have to call read bits.
Yeah, we're going to have to call, what's that other one? Bits per sample is the one that I'm doing now. Per sample is going to be that. And then total samples is 36. So that's going to be, all right.
And MD5.
MD5, 128. So that's the visible one. Yeah, it is. Okay. I'm going crazy here for some reason. Uint BE.
Right. No. This is no. It's in bytes. Well, it's divisible by 8. It's 16 bytes. It's an MD5.
It's a
basically hash of the data.
Yeah, it's a hash.
So we probably either want to return an octet vector, so read bytes, or the string representation of that, the hex string, which we should probably do in the AST.
Yeah.
another pass, basically. It's saying that it's 16 bytes, so we'll have it return 16 bytes, just a vector of bytes.
Okay. So now this is done. So let me just do this. We're good. For folks, we could actually go in.
That should actually work now, hopefully, if you compile that and run it.
I compiled
you have
it.
A whole data section filled with nice looking data.
What?
Requires one argument for parse metadata.
I did do that. Hold on.
That was in the macro, maybe, and you never compiled the calls to that macro? I don't know. Maybe. Parse metadata. No, it's in your other file on the right, no, it's up at the top there, yeah. That is compile that function and try it again.
Generic function requires at least one argument. Where is this error coming from? It's coming from... Let me just do this.
Parse stream. Parse stream is calling it too. Yeah, we screwed up. Parse stream should be parse metadata block, I think, right?
Yeah, that's right. That's the problem. Yeah. We renamed this without actually going to places where it was being called. Okay.
You're good. You don't got to compile any of that. Parse metadata cannot be called with stream info. Okay, so close that. Parse metadata block. Okay.
There's a problem.
Go to your define function at the bottom. Expand that. Comma M or whatever it is. I forgot.
Give me a second. I actually have a separate set of key bindings for that. Hold on.
Def method type equals stream info. Parse. Oh, you misspelled parse metadata in your macro definition.
Yeah. Jeez. Okay. Give me a second.
So compile the macro, then compile that define form again. You can close that. Yep, good.
There we go.
We got an object. That's good news. No, you just clicked on the slot rather than the slot value.
How do I go back? Now I keep forgetting this. It's
L, I think, or in
it's
SpaceMax. I'm not sure.
It's L. Metadata block. Stream header data. Here we go. Yay! We see it.
Look at that.
And it's beautiful.
It's a mono audio file, one channel.
Yes.
It's 16 bits. The bit count, or the bits per sample, is actually represented as 1 minus the actual.
Okay.
Or the actual minus 1. So yeah, everything looks perfectly cool. We got a standard sample rate of 44,000 hertz. Looks good. Nice stopping point.
Very, very nice stopping point. Okay, guys, I'll check this in. Again, for folks watching in the live stream, the code should be in the description. The repo is in the description, so go ahead and download it at your leisure. Play around with it, hack it around. We have the macro there for you guys to actually, if you guys want to go ahead and implement the rest of them.
And everything else is pretty easy by now because, that macro goes ahead and creates the class, and, all we got to do is set F every field just as it's written in the spec.
So one question I have is the use of the equal specializer instead of just doing. Could we have just simply done metadata stream info and whatever, right? A specialization function for each, or do you think that that would have been a little bit more code than just using?
Are you asking why we chose an
Yeah.
equal rather than a class dispatch?
Yes. Is it faster or is it?
Well, the concrete syntax tree has an integer for the block type, and we don't yet know the class when we call parse metadata block.
Got it.
The macro actually creates the class. So yeah, we could probably do it with a bit more code, but we're basically just mapping the integer that the spec provides to a keyword symbol, and that's why we're using equal.
Well, since we already have, I guess my question is since we've defined the class here, right? When we're defining the class, we could have just simply specialized it on the class at the same time, couldn't we? Or is there something?
Yeah, I think that would be perfectly fine. You're right. The only problem with that is then we would have to pass in metadata stream info rather than just the name of the type, which is stream info.
Right.
I mean, we could get around that with a little bit of hacking. No problem. No real reason.
Okay. I was just wondering if there's a performance difference between the equal specialization versus class
Not
dispatch.
at all.
Okay.
In fact, there's probably less of a performance hit because, it never has to compute any precedence list or anything like that to figure out the most applicable method.
Cool. Wondering if it's just any other questions from our audience and folks on the stream on what we just done. Sweet. Well, like I said, I'll check this guy in, and next week I'll see you guys, and hopefully we could come up with some other interesting things to do. So I'll see you guys next week.
See you then.
See ya.